In this presentation on number system, we are going to talk about the rational numbers, particularly in P by Q form. We start this presentation with the definition of rational numbers. So this word rational, it comes from the word ratio. So rational numbers, they are the numbers in the form P by Q. This P, it is called the numerator. This Q, it is called the denominator. And P can have value as any integer. We are saying P can be 0, 1, 2 or -1, -2, any value can be there for this P. And when we are talking about the denominator Q, we are saying it is a non-zero integer, that it can have any value except for the number 0, any integer value except for this number 0. And the collection of all these rational numbers, it is denoted by Q. This Q comes from the word quotient. So we can define the rational numbers as these are the numbers in the form P by Q such that P and Q are integers and the denominator Q is not equal to 0. So if we look at some examples, so we are saying it is the number in the form P by Q. So if we substitute the value of P is equal to 1 and Q is equal to 4, both of these are integers, we get the rational number in the form 1 by 4. If we substitute P is equal to -3, Q is equal to 2, we will obtain the rational number, it is -3 by 2. If we substitute say P is equal to 11 and Q is equal to 79, we will obtain the rational number, it is 11 by 79. If suppose we are substituting P is equal to -2001 and Q is equal to 2002, then we obtain the rational number in this form. So like this, by substituting different values of P and Q, we can obtain different rational numbers. Now next result we have is every integer is a rational number. So we are saying if any integer a is there, we can write that integer in the form a by 1. So suppose I am talking about the integer 79. So I can write this is equal to 79 by 1. So this is a number in the form P by Q where the denominator Q is not equal to 0. So it is a rational number. Suppose I am talking about the number -31. So this -31, it is an integer and I can write it in the form -31 by 1. So clearly this is also a rational number. Suppose I am talking about the integer 0. So 0 we can write in the form 0 by 1. Again we have this numerator can be 0. We are saying that this numerator P, it can be 0 but denominator can never be 0. So we are saying this number 0, that is an integer, it is also a rational number. So in general we are saying that every integer is a rational number. Now we can conclude from this that all rational numbers, they include natural numbers, whole numbers and integers. Now the next thing we are going to discuss over here, it is equivalent rational numbers. So suppose I am talking about a number 1 by 2. So what this 1 by 2 is representing, we are saying suppose we have a circle, then this 1 by 2 is basically representing the half part of this circle. Now next, suppose in place of dividing this circle in these two parts, we have divided the circle in 4 parts and we are considering, we have divided this circle 1, 2, 3, 4 parts and we are considering 2 of these parts. So what this will represent? This will represent a number. We are saying it will represent 3 by 4. Look at the area of both these circles. Basically, they are representing the same thing. So we are just saying that when we are talking about 1 by 2, we have divided this complete circle in 2 parts. Then one of its part, it is representing the number 1 by 2. Then we have divided this circle in 4 parts and we have selected 2 parts, so it is represented by the number 2 by 4. Next, suppose we are going to divide this circle in 6 parts and we choose 3 parts out of it. So this is represented by the number 3 by 6. And last we are saying, suppose we have selected or divided this circle in 8 parts and we have selected 4 parts out of it. So we will obtain the number. We are saying that this can be represented by this number, it is 4 by 8. Now if we look at these figures, what we can see that the region of the circle that is represented by all these parts, it is same. So we are saying that all these numbers, we can obtain some other numbers also. So we are saying that all these numbers, they are representing something that is same. So we are, based upon this, we are defining the equivalent rational numbers. We are saying that if we have rational numbers, they do not have a unique representation when particularly we are talking about the P by Q form. Unique representation means if we have to represent this portion, we can represent this portion by using any of these numbers. They are representing the same portion. So these kind of numbers, these are known as equivalent rational numbers. Now next we have to write is 4 rational numbers which are equivalent to 4 by 7. So the first rational number we are writing, the number we have, it is 4 by 7. If we multiply and divide the numerator and denominator by 2, we obtain a number that is equal to 8 by 14. So this is representing the first, or this is representing one of the numbers which is equivalent to number 4 by 7. Next, if we multiply and divide the numerator and denominator by 3, we obtain the number 12 by 21. If we multiply and divide the numerator and denominator by 4, we obtain the number, it is 16 by 28. If we divide the numerator and denominator by number 5, we obtain the number 20 by 35. So we are saying that all these numbers, 8 by 14, 12 by 21, 16 by 28, 20 by 35, these all are equivalent to the rational number 4 by 7. Now next we have is the term the simplest form of a rational number. So we are saying a rational number which is in the form P by Q, it is said to be in the simplest form if P and Q are integers having no common factor other than 1. So whatever rational number is given to us, if we are saying that P and Q are co-prime, that is they do not have any other factor, common factor other than 1, then that particular form, it is called the simplest form. So we give example over here to make you understand that what simplest form is. Suppose I am talking about the number 2 by 4. If the numerator we have, it is 2, denominator we have, it is 4, and if we calculate the HCF of 2 and 4, it is equal to 2. Now if we divide the numerator and denominator by 2, we divide the numerator and denominator of this number 2 by 4 by 2, we obtain the number, it is 1 by 2. And clearly we have in this number we are talking about, and we are talking about the number 1 by 2, the HCF of 1 and 2, that is equal to 1. It means this is the simplest form of the number 2 by 4. Next, suppose I am talking about the number 3 by 6. Now HCF of numerator and denominator, it is equal to 3. So we are going to divide the numerator and the denominator by 3. The number again we obtain, it is equal to 1 by 2. So the simplest form of 3 by 6 is 1 by 2. Next, suppose we are talking about the number 4 by 8. Again the HCF of 4 by 8, it is equal to 4. It means this is not the simplest form. We are going to divide the numerator and the denominator by 4, and the number we obtain, it is 1 by 2. So we are saying the simplest form means if we are talking about the number 2 by 4, the simplest form is 1 by 2. 3 by 6, the simplest form is 1 by 2. 4 by 8, the simplest form is 1 by 2. So simplest form just means that whatever number we obtain, if the HCF of numerator and denominator, it is 1, that is the numerator and denominator, they are co-prime, then that number is said to be in the simplest form.